Hey guys, it's Mr. C, and today I'm going to give you a video instruction on the closure properties of the different sets of numbers that we talked about last time when we classified real numbers. So today we're going to talk about how you can take some of these numbers and combine them and then see if the combination of the two numbers is still in its original set, or if it's in a different set, or if it's in none of the sets from Q on back or I. So let's take a look and see what happens here. And these are some very standard questions that you find on end of course tests. Here we have our graphic organizer of all the sets. So to review, we have natural numbers, whole numbers, integers, rational, which are fractions, terminating decimals, decimals that repeat, and then irrational, which is the exact opposite of rational. These ones, they just don't repeat and they never end for irrational. All right, so let's start out with a few questions. And this question is, determine if the statement below is always, sometimes, or never true. And it says, when you add two rational numbers together, the sum will be a rational number. So is that true? Well, I don't know. So what I like to do is I first like to see, can I show this in a general kind of a form? Which means if I take two generic fractions, rational numbers, all right? Let's say I have A over B, and I add that to another one, let's say C over D. Now the only thing I have to remember is B and D here, these two numbers, they're all integers, but these just can't be zero. Otherwise it wouldn't be rational. It wouldn't be anything. So just to remember, these two numbers can't be zero. All right, so if I add those two together, if you guys remember, there's a very easy way to add fractions. You could do the common denominator and those types of things you learned back in probably 6th and 7th grade. But if you remember, there's also what's called the butterfly method of adding fractions together. So if you add these two rational numbers together, the sum, then what you do is you take these two, A and D, and you can multiply them together. And then you can take these two, B and C, and multiply them together, plus BC, over, and then what you do is you take the two denominators and multiply them together, like that, BD. Now, that's how you add two fractions together if you use what's called this butterfly method, because it kind of looks like a butterfly when you get done. Well, if you look at this, that is in the form of a rational number. B and D weren't zero to begin with, so they're not going to be zero at the end. And then A, D, B, and C, those are all integers. If you multiply these together and then add them together, these two, you're going to get another integer. So if you add two rational numbers together, the sum will be a rational number. This is definitely in the form of a rational number. And so the answer to this one is going to be always, sometimes, or never. It's going to be always. So that's a good question. And if you ever want to prove something not to be true, you only have to find one counterexample to prove it not to be true, and then it's not going to be true. Could be sometimes, but we'll take a look at some of those too and see how those work. All right, so here's another one. And this one says, when you add two irrational numbers together, the sum will be an irrational number. Is that always going to be true? Sometimes, always, or never? Well, let's think about it. If you take, let's say you take the square root of 2 and add another square root of 2 to that. Okay, you're going to get 2 square root of 2's. Well, this number here is still irrational, because just because there's a 2 up front doesn't mean it's good now. It's still irrational because of this root 2 here. Put it in a calculator. You're going to get a decimal that's going to never repeat, and it's never going to end. So it's still going to be irrational. What if you take those two and it is addition, isn't it? When you add, okay, so we do have to add, so I can't subtract. What if I do this? What if I take the square root of 2 and the add to it is negative square root of 2? Is that irrational? I think it is. Negative square root of 2. That's still irrational, isn't it? It would just be the negative of this, but it's still irrational. If I take these two numbers now and I add them together, well, these are opposites because it's the same thing, plus and minus, the minus wins, and really what we have is root 2 minus root 2 which turns out to be 0. Now, is 0 an irrational number? No, 0 is actually a whole number, and it's an integer, and it's rational. So it is not going to be irrational here. So what happens is that you get it here, which is true. That is irrational, but here is false. That's not irrational. So always, sometimes, or never. Well, we have to say sometimes this time, because sometimes it is and sometimes it is not. And there are cases where it's not, and this is generally the case where that's going to happen. When you add the opposite of that irrational number, you're going to get 0 every time, and that's going to give you a whole number or an integer or a rational number. So that's a good question. Let's try this one. When you multiply two rational numbers together, the product will be a rational number. Always, sometimes, or never. So let's take a look. If you take two rational numbers, so again, we're talking about fractions, right? I'm kind of switching back and forth, so you have to have a good feeling for these sets. Let's say we take our a over b, rational, and we multiply that by c over d this time. Well, if you remember, when you multiply two fractions together, you multiply across, don't you? So we have a times c over b times d. And again, b and d are both non-zero, so we're okay. But if you look at a, c, and b, d, these are all integers to begin with, because that's the definition of a rational number. All of these are integers. And when you multiply two integers together, you're going to get another one. So therefore, you have integer over integer, and it is always going to be a rational number, because this is in the form of a rational number when you get done. You can try a bunch of examples, and it's going to work every time. So that one's always. Sometimes these questions are kind of hard, because in order for it to be sometimes or never, you have to come up with that counterexample, which can be sometimes difficult. So let's take a look at this. When you multiply two irrational numbers together, the product will be an irrational number. All right, so let's take a look at a couple examples. Let's take the square root of 2 times the square root of 3. Okay, now, these are both irrational numbers. Never repeat, never end as a decimal. If you multiply these together, if you remember your rule, you actually multiply the 2 and the 3 together. So what happens is, by the rule, you get 2 times 3 underneath the radical here, and so you get the square root of 6. Well, you put square root of 6 in your calculator, and you're still going to get an irrational number. You're going to see that decimal go forever and ever, and it's never going to repeat. So that one is irrational. Okay? So let's try another example. How about if we just take the square root of 2 times another square root of 2, though? What happens here? Well, if we do that, by the same rule, we're going to get 2 times 2 underneath the square root, but 2 times 2 is 4. But the square root of 4 is 2. And so what happens is, we get 2 here for this one. 2 is what? Let's talk about that. That's going to be a natural number, right? It's going to be a whole number. It's going to be an integer. And it's going to be rational. So, is it irrational? No, it is not. It's the exact opposite of irrational. So what happens is sometimes you get an irrational and sometimes you do not. So with that little counterexample, this one is going to be sometimes. Great EOC questions. They love to ask this stuff. Let's try this one. This one says, when you add a rational number and an irrational number, the sum will be an irrational number. Is that going to be true? Well, let's take a look. This one's a little harder to prove, but let's take a rational number like 2, and let's add the square root of 2 to that. Okay, I can't really simplify that. That is not 2 root 2. So if I write equals 2 root 2 here, if you put these two decimals, these two in the calculator expressions, they're going to be different. That is not true. Okay, so you can't do that. It's not going to be 2 point root 2. That's not going to happen. It's not a mixed number. So what happens is this number is, that's it. That's the only way you can write it. And if you add a rational number to an irrational number, if you think about it, on a number line, you would go a distance of 2 and then another little square root of 2, and which is irrational. The problem is it's still going to give you an irrational number every single time. So there's not really a way to add a rational and an irrational and get something that's rational. So this guy right here, whenever you add those two together, rational and irrational, you're going to get irrational. So this one is going to be definitely going to be always. Okay. And again, you can look at this video again and pause it and look at the slide just to make yourself, feel good about what I'm doing here and thinking about it, because these are all thinking questions. Okay, here's another one. When you multiply a rational number and an irrational number, the product will be an irrational number. Is that true? Well, let's see. Let's take 2 for our rational, and let's take again the square root of 2 for our irrational. See, sometimes I write 2's differently. That's fine. I always do that. Okay, so if you multiply these together, this in fact does equal to root 2 because you have 2 of them. Is that rational or irrational? Well, that number right there we already talked about. The square root of 2 is irrational. Doubling it doesn't really help you at all any. And if you put this in the calculator, it's still going to be irrational. It's just double this that was irrational to begin with. So the thing is when you multiply these together, you're going to get an irrational number. Okay, so let's try something else. Here's another rational number. What about 0? 0 is definitely rational. And you multiply that by root 2. Well, the product of 0 and any other number is 0. So what happens there? Well, 0 is a whole number, it's an integer, and it's a rational number. So what happened was we got one time irrational, one time something else. And so the answer to this question then, when you multiply a rational number and an irrational number, the product will be irrational. That's false because here we got one that was not. So we have one that is and one that isn't. And when that happens, that's where you have to do sometimes. Sometimes it is, and then sometimes it isn't. And there's lots of questions you can make like this. These are just a few examples of how to think about solving a question like this. All right, so let's talk about closure. What does closure mean? A set is considered closed under an operation if an operation would be addition, subtraction, multiplication, or division. Okay? Under an operation, one of these big four, if any two members of the set result in another member of the set after the operation is applied. So let's talk about this. What if you take the set of natural numbers? 1, 2, 3, 4, and so on. If you take any two of these members of this set of natural numbers and you, let's say, add them together, 3 plus 1 is 4. 2 plus 3 is 5. It's going to come up at some point in time. We would say that the set of natural numbers is closed under addition because whenever you add two of them together, you get another one, right? So what we're going to have to do is we're going to have to take each of these sets and figure out if they're closed or not closed under some of these different operations. So that's just one example of what we're about to do. So closure is another end of course type of a topic that they like to ask. Okay, so that's what closure means. Now, let's take a look at these. Determine if the set of natural numbers is open or closed under each operation. Okay, so is it closed under addition? Well, we just saw in my previous example, yes, it is closed under addition. If you add any two natural numbers together, you're going to get another one. What about subtraction? Subtraction's a little bit trickier because for subtraction, if you take, and I'm just going to do some work up here if that's okay. If you take, let's say, 1 natural number minus 3 natural number, you get -2. Not a natural number. So what happens is that's outside the set. And since that's outside the set for subtraction, we would say that it is not closed. Okay, now what about multiplication? Well, if you take any two natural numbers, let's take 3 and 4. If you take 3 times 4, you get 12. That is definitely still a natural number. So any two natural numbers you multiply together, you're going to get another natural number. There's no way to get out of the set with multiplication. So we would say that that one is closed. And for division, division's interesting because what if we take 1 and we divide that by 2? Now those are both natural numbers, but 1/2 is not a natural number. So we're now outside the set and we say that that one is not closed. All right. So let's take a look now at whole numbers. For whole numbers, it's a lot like natural numbers because we only add 0 to it, right? It's the natural numbers 0 and 0. 1, 2, 3, and so on. So we only add 0 to it. What about addition? If you add any of these together, is it going to result in another one down the line? And that would be yes. So it's closed under addition. If you subtract, we're going to have the same problem we had before with natural numbers. You're going to get negatives. Not closed. If you take multiplication, if you multiply any of these together, you're going to get another one, another whole number. Closed. Division, we're going to have the same problem we just had with natural numbers. 1 divided by 2 is still 1/2, and you're still outside the set of whole numbers. So it's going to be not closed. And sometimes they'll want you to provide an example of why it's closed or why it's not closed. And some of the examples that I just spoke of would suffice for that. All right, now let's take a look at integers. So now things are going to get a little bit more interesting because we're going to have to think a little bit harder here. If you take 2 integers and you add them together, okay, so integers, -3, -2, -1, 0, 1, 2, 3, ... If you take any 2 of these and add them together, are you going to get another integer? And the answer is going to be yes, closed. If you subtract any 2 of them, are you going to get another integer? And now the answer is yes, because now we have integers available that are negative over here. So now those are okay. So if we take 1 minus 3 again, and we get -2, we're in good shape because -2 is an integer. So it is closed under subtraction. Is it closed under multiplication? If you multiply any 2 of these together, are you going to get another one? And the answer is going to be yes. What about division, though? Well, we have the same problem we had before. If you take 1 divided by 2, 2 integers, and you divide them, you get a number that is not found in this list. And so we would say that is not closed under division for integers. All right, so let's talk about rational numbers now. For rational numbers, if you add 2 rational numbers together, 2 fractions, do you get another fraction? And we already looked at that at the beginning of the video, and we said that the answer was yes, you get another one. Subtraction is really the same thing as addition, you're just adding a negative. So what happens is you're gonna get a fraction again, but you can get negatives also. And rational numbers do contain negatives. That is fine. So we are closed under subtraction. Multiplication. Well, we already saw that when you multiply 2 rational numbers together, you get another one. Remember when we did a over b times c over d? And we multiplied that together and got ac over bd. Again, another fraction, another rational number. So it's closed under multiplication. What about division? Well, here's the tricky thing. We can divide 2 fractions, no problem, as long as we don't divide by 0. So I'm going to write down here. It's okay as long as division is not, I'll just write it across here, by 0. So if you exclude that possibility, which nobody's going to divide by 0 anyway because you're not supposed to, it's garbage, you don't get anything, it is closed under division. So that's a very interesting set right there because you get closure for all 4 of them and the other ones you didn't. So that's very good. Okay, our last set to talk about is irrational numbers. This is interesting. So if you add 2 irrational numbers, are you closed or not? Are you going to get another irrational? Well, as we already saw, the square root of 2 plus the square root of -2 we saw was 0, right? So that, since it resulted in a rational number right there, it is not closed under addition. So what about subtraction? Well, let's take a look. Same idea. Root 2 minus root 2. Take any two irrational numbers, subtract them. You get 0 again. Rational. So it's not closed under subtraction. What about multiplication? We talked about that. Root 2 times root 2. We saw that that was root 4, and root 4 is positive 2. That is not an irrational number. So it is not closed under multiplication. What about division? If you divide two irrational numbers, are you going to get another irrational number? Well, if you take, let's say, the square root of 2 divided by the square root of 3, that's going to be irrational. And the reason why is because you could actually write that using the rule of square roots like this. The square root of 2/3 is definitely irrational. But here's the problem. If you take the square root of 2 divided by itself, which does qualify because they're both irrational, right? You get 1, which is rational. And so the issue here is there is a possibility where you can divide two irrational numbers and get a rational number at the end. So that set is not closed under division. All right, guys, so this is going to conclude my video lesson on sets of real numbers and the closure properties. And I hope this helps, and have a great day. We'll see you guys.